Okay, ladies and gentlemen, now that we have finished surface area of our three-dimensional figures, we are going to focus now on volume of our three-dimensional figures. I think you'll find that the volume formulas are a little bit easier and a whole lot shorter than some of your surface area formulas. So you might like this just a little bit better. At the top, we're going to talk about what volume is. So I have a definition up here that volume is the amount of space that an object occupies, so what it can hold, and it's three-dimensional, therefore it's measured in units cubed because it takes up length, it takes up width, and it takes up height. Okay, so for the first one, examples. Filling pool with water would be volume. How much water can you put in that pool? The amount of soda in a can is considered volume, where surface area would be how much metal did it take to make the can. Volume is how much soda can you put in the can. So that's where your difference comes in. So volume is always calculated by finding the area of the base and multiplying. I'm going to squeeze that in there by the height. So there's a general formula here, but we get more specific as we go through. So the general formula would be the volume equals the area of the base times the height. Now that's, again, very general. So we're going to be very specific, though, when we actually get into the solving process. So the first thing we're going to look at is our rectangular prisms. Our rectangular prism is a box. And the volume is simply finding the length times the width times the height. That's it. Super simple to do. Really just making sure you label what is the length, what is the width, what is the height. So you always want to label those. And we're just going to multiply those pieces together. So the length is 4. The width is 3. The height is 2. We're going to multiply 4 times 3 times 2. And we get 24 meters cubed. That's simple. Next one. Again, if you'd like to try these on your own and then check back with me, you're welcome to pause the video and then try them on your own and then check and see if you did them correctly. If you're not comfortable yet, feel free to just follow along with the video. So this is my length, this is my width, this is my height. So I'm just going to take those 3 pieces, 7 times 2 times 3, multiply them all together. 7 times 2 is 14, times 3 is 42, and our units are meters cubed. Now, when we're talking about a cube, remember, this is length, this is width, and height, all 3 of them. So our volume is 6 times 6 times 6. So we get a volume of 216 meters cubed. All right, so that's the easiest formula probably that we have. All right, next figure, square-based pyramids. A little bit different on these formulas. We got that big B involved in the square-based pyramid, and the big B stands for area of the base. So it's area of a square. H is the true height. Now we talked about a slant height when we did surface area, but a true height is an interior height. So if you notice that the line for the height is coming inside and should meet dead center of the base at a right angle. And these did not show up very clearly. Those are 6s and this is an 8. The 1/3, just hold on to that. We're going to talk about that at the end. Area of the base. So how do you find the area of a square? You take the 2 sides and you multiply them by each other, or you square it, either way. So the 2 sides of my base are a 6 and another 6. My height is the true height line. That's 8. So the first thing I'm going to do is multiply 6 times 6 times 8. That's 288. I'm going to save this 1/3. So instead of trying to deal with this 1/3 as a crazy long decimal, just remember that multiplying by 1/3 is the same thing as dividing by 3. So I can take this, divide by 3, and get 96. Okay, so I'm going to write that down off to the side over here, that multiplying by 1/3 is the same as dividing by 3. So that makes life a little bit easier and you're not dealing with 1/3 as a decimal, okay? All right, let's look at some more of those. Again, if you want to try these on your own, feel free. If you're not comfortable yet and you want to work with me, feel free to do that as well. All right, so we have a square-based pyramid. I know it's a square-based pyramid because these two sides are the same. My volume is 1/3 the area of the base. So I'm taking these two 8s and I'm going to multiply them together. That's the big B, times the true height, 9. If they give you a slant height, then we got a problem. We're going to talk about that in the next one. So we've got volume is 1/3. I'm going to multiply 8 times 9. That's going to give me 576. I'm going to take this number, divide it by 3 to get a total volume of 192 centimeters cubed. All right, so what happens if we have a situation like this? Here, they've given us the lateral height. This is that L. They didn't give us the true height. We are missing this true height that comes here down in the middle. But what I will tell you is you can use your Pythagorean theorem, and you are going to have to do this. So if I draw this right here, what I notice is I have a right triangle, okay? So I need to figure out the distance from here to here. This is my hypotenuse, and I can find this leg. So if 6 is all the way across, and if this meets in the center and goes to the edge, it's half of 6. So this is 3 centimeters. And then I'm missing A. So I can do a quick Pythagorean theorem here. So I'm going to do A squared plus 3 squared equals slant height 12 squared. So that's going to be A squared plus 9 equals 144. We have to subtract 9 from both sides, and we get A squared equals 135. Take that square root, and we get A is about 11.6. This is now our height of our pyramid. So now we can go about and find volume. So my volume is 1/3 area of the base. It's a 6 and another 6. So I'm going to multiply those together. That's area of the base. We just found the height here at 11.6. So again, I'm going to leave this 1/3 alone and just multiply these two pieces together. That's going to give me 417.6. And then taking 1/3 of that, dividing by 3, 139.2, and we're in centimeters, so it's centimeters cubed. Our last figure that we have to deal with is the cone. And that cone has that 1/3 thing going on there too. So we're going to talk about that just like we did in the other one. So our cone is 1/3 pi r squared h. Once again, you have to have the radius. If they give you a diameter, you've got to split that, okay? So 1/3 pi radius squared and true height, inside height. If they give you the slant height, you would have to use that Pythagorean theorem again. So I'd have to square this first. That would be 4. And then from there, and I can put that underneath here, I'd multiply 3.14 times 4 times 8. That's 100.48. And then I'm going to divide this by 3 because that's taking 1/3 of it. So it's about 33.5 inches cubed. Not hard formulas, and definitely much, much shorter than some of the other ones that we were dealing with. Okay. Now on the bottom here, if you notice, this one's a little bit different. They're showing you the true height, but they're showing it on the outside instead of putting a dotted line on the inside. If it goes from tip to base, then this is your true height line here. And then we do have a radius, which is nice. So we can use exactly what we have in this picture to find our volume. So it's 1/3 pi radius squared times the height. We do have to square that radius first. We're going to leave everything else alone. That's going to be 36 times 12. And again, I'm going to leave this 1/3 and multiply all 3 of these pieces together here. It's going to give me 1,356.48. And then I'm going to divide that by 3. So that's going to give me 452.16. If we are rounding to the nearest tenth, that's 452.2. And we're in, that's actually unit for feet cubed. Okay. And last but not least, we have this cone. Now, the thing with this one is they've given us a diameter. We need a radius. So I can't use that number. My radius here is 9. And they did give us a true height, not a slant height. So I don't have to do a Pythagorean theorem here. So it's just going to be 1/3 pi radius squared times height. I do have to square that first. So I get 1/3 pi 81 and 18. I'm going to multiply all 3 of these pieces together. That's going to give me a pretty large number, 4,578.12. And then I'm going to divide that answer by 3, 1,526.04. If we are rounding, 1,526.0, or just 1,526, and we're in miles, so miles cubed. So this is our volume. Need to know your formulas, have them ready, have them handy. You don't have to memorize them, but you definitely need to have them handy so you know what you're looking at. Tomorrow, we're going to be working on application problems, so word problems dealing with volume. I hope everybody has a great day, and I'll talk to you soon.